Hello and welcome back to some trig videos. So the quiz that you took last was just kind of like the halfway point of the trig unit, and we still have a bunch of days to go, a couple weeks of this left. So this is unit 13, day 7. Today should be a little bit shorter of a video. We're talking about something we're going to need for stuff later on, the signs of trig functions and all the quadrants, and that means whether they're positive or negative. So it says consider angle theta that intersects a circle with radius r as shown below. So we talked about this with a unit circle before, but now I'm saying this could be any circle. It doesn't have to be a radius of 1 anymore. So sine of theta on this circle, still just using SOHCAHTOA like always. SOHCAHTOA. Sine of theta, which is opposite over hypotenuse, would be y over r. Cosine of theta, adjacent over hypotenuse, would be x over r. And what would tangent of theta be? Y over x, just like it was for tangent of quadrantals. So now I want to use that to figure out in which quadrants is sine greater than 0, less than 0, etc., etc. So to do this, I'm using this idea up here, and I'm going to kind of draw down here a little bit before we answer those questions. This is the x coordinates, these are the y coordinates. So if I'm in quadrant 1, these x values are positive and these y values are positive. So in both of these, x is positive and y is positive. Okay, so over here, these are negative x values, and up here still positive y values. So in this quadrant, quadrant 2, x is negative, y is positive. What could you tell me about the coordinates in quadrant 3? Right, they're both negative. X's are negative and y's are negative, and this is why we had certain sides of triangles when we were drawing them be negatives. Quadrant 4, x's are positive over here, but y's are negative. So that's going to affect which sides are opposite, which sides are adjacent, and whatnot, are going to affect which trig functions are positive and negative. So the only thing I haven't talked about in all of these is r, and r is the radius of a circle. And whenever we were drawing these triangles, what signs did r always have? R was always positive, right? So I'm going to make a note of that also. Recall r is always positive. Okay, so I want to know now in which quadrants is sine positive and sine negative. Greater than 0 means positive, less than 0 would mean negative, right? So sine was y over r. And again, r we know is always positive. So what's going to make this fraction positive or greater than 0 is if y is positive. So which quadrants are y positive? 1 and 2. So sine's positive in quadrant 1 and quadrant 2. By the same token, whereas sine less than 0 means this piece would need to be negative, so it's quadrants 3 and 4 are the other ones. Cosine. Cosine on that picture up there was x over r. So cosine being positive, what quadrants do you think cosine is positive in? Right, it's where x is positive, which is quadrants 1 and quadrants 4. So where x is negative is where cosine would be negative, which are the other two quadrants, quadrants 2 and quadrants 3. And the last one is tangent. Now tangent's a little trickier because remember from the picture, tangent's y over x. So r is not involved in all. So how would tangent be positive? How would y divided by x end up a positive number? Look at your picture and think about what quadrants that would be. Quadrant 1 for sure, because you would need y positive and x positive. So quadrant 1. Where else would that end up being positive? Right, quadrant 3. A negative divided by a negative is also positive. So y positive and x positive and y positive. All right, it didn't come out very well. Let me write it again. X positive and y positive, or x negative and y negative. So that's quadrant 1 and quadrant 3, where tangent's positive. So where's tangent negative? Where the opposite is true, where one of them is positive and the other is negative, or vice versa. So it'd be quadrant 2 or quadrant 4. Okay. Now that's hopefully makes sense on why this is where sine, cosine, tangent are positive and negative, but it's kind of a long way, or it takes a long process to go through all that analysis. So there's also this quick way to remember where each function is positive. And that's this thing ASTC. The A stands for all, because all of the trig functions, sine, cosine, and tangent, are positive in quadrant 1. What do you think S stands for? Sine, because in addition to quadrant 1, sine's also positive in quadrant 2. You can see the other one tangent is positive in is quadrant 3, which is why there's a T down here for tangent. And obviously the other one where cosine's positive is quadrant 4. So ASTC. There's different ways to people to remember this. My trig teacher in high school said all students take calculus, but that's only sort of true because some of you might not ever take calculus. The more general one is all students take classes, because that's definitely true, so you can think of that. But the one that I've found to be the most accurate and true is all students try cheating. ASTC, all students try cheating. Def true statement. So this tells you where all of the trig functions are positive. So for example, if I asked you where is sine positive, you'd say quadrants 1 and 2, because all and sine. If I asked you where cosine was positive, you'd say 1 and 4, because all and cosine. All always gets included. And if I asked you where tangent was positive, you'd say all and tangent. And what if I asked you where sine was negative? Well, again, this is telling you where it's positive. So if it's positive in 1 and 2, sine's negative in not 1 and 2, or 3 and 4. What if I asked you where tangent was negative? What would you say? Not these, so 2 and 4. Or if I asked you where cosine is negative, not those, so S and T. So you can use this to find where they're positive, and you can use kind of the opposite of that answer to find where they're negative. Okay, if you go to the next page, or last page, we'll have some questions like the homework. Use the given information to determine which quadrant the angle lies in. Okay, so we've got sine is greater than 0. Sometimes I like to write what that means. That means sine is positive. and cosine is less than 0. Cosine's negative. So draw out your all students try cheating. Okay, and we're going to circle. Where is sine positive? Again, this tells you where they're positive. So sine's positive in all and S. So I would circle this. Where is cosine negative? So cosine's positive in A and C, so where's negative? S and T. So if both of these things about angle theta are true at the same time, what quadrant would you have to be in? It's the overlap. So you're in quadrant 2. This is tangent of omega and cosine of omega, just a different variable, just so you're used to seeing different ones. They're saying tangent of omega is negative, less than 0, and they're saying cosine of omega is positive, greater than 0. So draw out all students try cheating. If you want to pause the video real quick and see if you can try this one on your own, wouldn't be a terrible idea. You're ready to see the answer. Tangent negative, what'd you circle for that? Tangent is positive in 1 and 3, so it's negative in 2 and 4, S and C, so not all in tangent. And then where's cosine positive? 1 and 4. There's the overlap, so we should have said quadrant 4 for that one. Make sense? Hope so. Okay, now this one, a little bit different. All students try cheating. We've got secant is negative and sine is positive. Well, if sine's positive, I can do that really easily. What am I going to circle for sine positive? A and S. But what do you think you're going to circle for secant negative? What's secant related to? Cosine. So let's make something up. If secant of alpha was, I don't know, negative 2/3. I don't know what number it is, but it just tells me that's negative. How is secant related to cosine? Well, instead of being negative 2/3, it's the reciprocal of that. Don't say opposite. Instead of adjacent over hypotenuse, it's hypotenuse over adjacent, but cosine's still negative. So I did that to show you that taking the reciprocal of something doesn't affect the sign of it. So if secant's negative, cosine's negative also. So taking reciprocal does not affect positive or negative. So the important thing to know is when you see one of those reciprocal trig functions, just write it in terms of the other one. So cosine of alpha is also negative. Okay, so now knowing that, if cosine is negative, what are you going to circle? Not where it's positive, so S and T, and your answer is quadrant 2. Okay, last one. Cotangent of alpha is 4/3. So what does that also mean? It means tangent of alpha is 3/4, which means tangent is positive. And cosecant of alpha is negative 5/3, tells you what? Tells you that sine of alpha is negative 3/5. So it's telling you that sine is negative. All students try cheating. Tangent of alpha is positive. So if I want tangent to be positive, I'm going to circle A and T. If I want sine to be negative, I'm going to circle not 1 and 2, so 3 and 4. And my answer is quadrant 3, the overlap. So that's kind of building up to this last example. If sine of theta is 1/5 and cosine of theta is less than 0, and I again like to write negative right away, find the value of tangent of theta, so that's our goal, in simplest radical form. So anytime I've found a trig function so far, I've always ended up drawing a picture. So that's what we're going to need to do. But in order to draw a picture, I got to figure out where I'm going to draw it. Usually I have an angle. That's how we've been drawing it up to this point, but this is just theta. So the first step is to figure out which quadrant. And that's where we use the information that was just given to us. Sine of theta is 1/5. That's also telling us that sine of theta is positive. And we know that cosine of theta is negative. So if I use all students try cheating, what am I going to circle for sine of theta positive? 1 and 2. And for cosine of theta negative, negative means not A and C, so S and T. So I'm in quadrant 2. So I can definitely draw an angle theta. That's technically theta in quadrant 2. I'm just going to label this as theta as my reference angle. Okay, that's the first step. Now the second thing I usually do once I know the angle is I label the sides. I don't know the angle, so I don't know the sides. Except I know that sine of theta is 1/5. So I can use that. So second step is to label triangle. Sine of theta is 1/5. So 1 is which side? It's the opposite side. So opposite of angle theta has to be 1. And 5 is the hypotenuse. How can I get that other side? Pythagorean theorem, right? It's a right triangle still. So 1 squared plus b squared equals 5 squared. 1 plus b squared equals 25. B squared equals 24. Take the square root. Now square root of 24, you've got to think of that as the square root of 4 times 6, because 4 is a perfect square. So b is 2 radical 6, but be careful. When you take a square root in a math problem, the answer is not just 2 radical 6. What's the other possibility? Taking a square root, remember, gives you plus or minus. And now you have to decide, should that side be positive or negative? It's negative. It's going to the left. So negative 2 radical 6. Okay, now my triangle's labeled. So final step is to find answer. And I was looking for tangent of theta. So tangent of theta in simplest radical form, it's opposite over adjacent. Opposite is 1. Adjacent is negative 2 radical 6. Is that simplest radical form? No, because there's a radical in the bottom. What do you need to multiply top and bottom by? Some of you might have said negative 2 radical 6. The negative 2 is not under the radical, so that can stay down there just fine. It's just the radical 6. So if I multiply top and bottom by radical 6, I'm still multiplying by a ratio equal to 1. So it's like I'm not changing the value, I'm just multiplying by 1. So 1 times radical 6 on top is radical 6. And negative 2 times, this piece is 6 together, so negative 2 times 6 is negative 12. So my answer is negative radical 6 over 12. And you can't reduce stuff that's inside a radical with the stuff that's outside the radical, so that is simplest form. All right, that's the end of my notes. You should have this homework sheet. Just know that throughout this, you're using ASTC. It's all about that. So I think pretty much every question has to do with that. So this one's telling you about cosecant positive and secant negative. Use that to figure out what quadrant you're in. Same idea with this one. This just wants you to determine the sign. So this is saying if I'm in quadrant 2, and I'm a cotangent, would cotangent be positive or negative here? Well, okay, so cotangent is related to tangent, and tangent would be negative here, because tangent's positive here and there. So if tangent's negative here, cotangent's negative also, so the answer is just negative. That's how you do those ones. On the back is more like what we just did. 5 is written a little weird. When drawn in standard position, an angle theta or alpha has a terminal side that lies in the second quadrant, whose sine equals 9/41. It's kind of doing what we just did, but easier. They're telling you what quadrant you're in. They're telling you, okay, you're in the second quadrant. And they're telling you that this is opposite over hypotenuse, because that's sine. So you can label 9 and 41, and then you can go from there, find the cosine of that angle. 6 is like what we just did. And 7, same idea, but it tells you what quadrant you're in. And it gives you cosecant. And they want you to find all the other ones. Okay, so use your answer key to check, but that should give you a head start. Let me know if there's any questions. Good luck.